Alright, welcome everyone. Today I'm going to be discussing the problems and solutions for the AMC 8 from 2016. If anyone has any questions during the explanations, please leave your questions in the chat and I'll get to them as soon as possible. We'll start with question 1. So we're told that the longest professional tennis match ever lasted 11 hours and 5 minutes, and we want to know how many minutes this was. So since there are 60 minutes in an hour, we'll start with 11 times 60, and this would be 660. So that's going to be 660 minutes from the 11 hours. And then we add 5 for the leftover 5 minutes. And we get 665. Pretty straightforward question. Let's go on to question 2. So in question 2, we're given a rectangle, and we are, not too difficult, right? Okay. So we have a rectangle and its sides are 6 and 8. We have, let's label their sides A, B, C, and D. Whenever you're labeling the sides, make sure you always go in order around the shape. So A, B, C, D. Going around, you don't want to do A, B, and then, skip to the top right. You wouldn't want to go A, B, C, D. So we have AB is 6 and AD is 8. And we're told M is the midpoint of AD. And we want to know the area of AMC. So that would be a triangle like that. So to find the area of this triangle, we'll use base times height divided by 2. And that works even when we have an obtuse triangle like this. We can use AM as our base. Since AD was 8, AM will be half that distance. Since M is the midpoint, it'll, split AD into 2 equal parts. So remember, this 8 is the entire AD, this 4 is AM. And then for the height, we wouldn't want to use CM. We want to draw a line that's perpendicular to the base, which is AM. So CD is the line perpendicular to the base, and D is on the line AM. So that's our height. And because we have a rectangle, AB will be the same as CD. So our height is 6. And then we finish with base times height divided by 2. So that would be 4 times 6 divided by 2, which is 12. Okay, so our answer is A. Question 3. We have 4 students who take an exam. 3 of their scores are 70, 80, and 90. We know their average is 70 across all 4 students, so we want to know what the remaining score is. So we know that the average is the total divided by the number of students. So if we take the average and multiply by the number of students, which is 4, we should get the total score, which is 280. And we know that 3 of their scores were 70, 80, and 90. So we can find out what 3 of the scores add up to. If we use 70 plus 80 plus 90, that's equal to 240. So to find the last score, we just do 280 minus 240, and we get A, 40, as our final answer. Another way we could do this problem is say like 70, because it's the average, sort of like the flat line. And then we have 80, 90, which 80 is 10 above the line, 90 is 20 above the line. So to cancel these out, basically, we need a number that is 30 below the line, because there's a combined total of 30 above the line. So we need a number that's 30 below the line. So 70 minus 30 is 40. It's another way we could have done it. Okay. Question 4. So we have, when Shinu was a boy, he could run 15 miles in 3 hours 30 minutes. And as an old man, he can walk 10 miles in 4 hours. So we want to know how many minutes longer it's taking him to walk a mile now. So this is a rate problem, so we want to find out how many minutes per mile he takes as a boy and as an old man. So first we want to convert to minutes. 3 hours and 30 minutes. We'll do 3 times 60 for the 3 hours, and then add the 30 minutes, and that's 210 minutes. If we do 210 minutes divided by 15 miles, that's 14 minutes per mile. Odd units here. 210 minutes over 15 miles. And then as an old man, he walks 10 miles in 4 hours. So we do 4 times 60. And that's equal to 240 minutes. So if we divide that by 10 miles, 240 minutes divided by 10 miles, that's going to be equal to 24 minutes per mile. So the problem is asking us for the difference, which is 24 minus 14, so our answer is 10. Alright, problem 5. We know that the number n is a 2-digit number, and we know the following 2 statements. When n is divided by 9, the remainder is 1, and when it's divided by 10, the remainder is 3. We want the remainder when n is divided by 11. So when n is divided by 10, the remainder is 3. This is a very useful condition because it basically tells us the ones digit of the number. Right? We know that n has to end in 3 because that's the only way the remainder can be 3 when we divide by 10. So we're looking at a 2-digit number that ends in 3. We also know that when divided by 9, the remainder is 1. So if we take the number and subtract 1, then we would get a number that's divisible by 9, basically, because we're subtracting that remainder, so we should get a multiple of 9. So the new number after we subtract 1 would be the same thing, but it would end in 2. So we need the multiple of 9 that ends in 2. And if you go through the multiples of 9, you'll get that it's 72. You could try 12, 22, 32, 42, all the way up, and you get 72. So the original number was actually 1 greater than this, so it would be 73. And when we do 73 divided by 11, the biggest factor of 11, or the biggest multiple of 11, less than 73 is 66, so the remainder is 7. You would get 6, remainder 7. Okay, so C, A, A, B, E, those are the answers for the first 5 problems. Any questions? All right, move on. So question 6 says that we have a bar graph representing the length and letters of the names of 19 people. and we want to find the median length. So we're given 3, 4, 5, 6, or 7. And then here's the bar graph. So we can see that on the x-axis we have the length of the name, and on the y-axis we have the frequency. So to find the median, we want to find the name that's in the very middle, basically. And that's when all the names are in order. So they're already in order for us, so we just have to find the middle name now. So we see that we have 7 people here with 3 letters, and we could get rid of 7 people from each end. So there would be 4 here, and then we would get rid of 3 more people here. Basically what we're doing is crossing people off the ends to leave us with the person in the middle. So then there's 1 more person here, which would eliminate 1 more person here, and then we're left with 3 people. 2 people have 4 letters, 1 person has 5 letters, so the person in the middle would be one of the people that has 4 letters in their name. So the answer would be 4, which is B. I won't scroll back up, but the answer is B, 4. Alright, next question. We're asked, which of the following numbers is not a perfect square? So you'll recall that perfect squares are a number where there's some other number that when multiplied by itself equals the original number. So this can happen when the exponent of a number is even. So for example, 5 squared. Because the exponent is even, we can split it in half and do 5 to the first power times 5 to the first power. Similarly, for 7 to the 6th, we could do 7 cubed times 7 cubed. So we can eliminate any number where the exponent is even. So it would be A, C, and E. Those all don't work. They're definitely square numbers because the exponent is even. And now we're left with B or D, one of which is a square number and one of which is not. Now the key here is that 4 itself is a square number. And you can try this for yourself, but you'll notice that if you multiply a bunch of square numbers together, you still end up with a square number. So for example, if I take 9, multiply by 16, that's 3 squared times 4 squared. I'll get 144, which is just 12 squared. So because 4 is a perfect square, what you'll end up getting is 2 to the 2019th squared. So this is equal to 2 to the 2019th power squared. Now that doesn't work for B because the base is only 2. So B is our answer. And note that it didn't actually matter if the base was even, but it did matter in D because 4 is a square number. Okay, move on to the next question. Oh, yes, 1 is a square, so that is another reason that A would also not work. So A doesn't work because the exponent is even. It also doesn't work because 1 is a square number. And obviously 1 multiplied by itself 2016 times, you still get 1, and 1 is still a square number, right? Okay. Problem 8. So we want to find the value of this expression, which starts with 100 and minus 98 plus 96. So alternating minus and plus, and then going down by 2 every time. So what we can do is pair up numbers that are close to each other. That way we can get friendlier numbers. Like that. Okay, so we can see that each parentheses has 2 within it, right? 100 minus 98, 96 minus 94, and all the way down, it's always 2 on the inside. So all we need to know now is how many of these parentheses there are. So we can see that the numbers go from 2 to 100, but it's only the even numbers. So that would be half the numbers from 1 through 100. So that would be 50 numbers. But each parentheses has 2 numbers inside, so there's actually only 25 parentheses. Because 50 numbers paired up, that's 25. So our final answer would be 25 times 2, since each parentheses has a value of 2 within it. And that would give us a final answer of 50. Okay, problem 9. We want to know the sum of the distinct prime integer divisors of 2016. There isn't really any smart way to do it. We just have to go through the division. So we can start by dividing by 2. That's pretty clear that we can do since 6 is even. So I'll just go through the factorization now. 504, 252. So each of these is a factor of 2. So that's a total of 5 2's, 2 to the 5th power. And then we're left with 63, which is 3 squared times 7, 9 times 7. And you can check this on your own if you want. So now all we have to do is just add up each of the primes, so 2, 3, and 7, and that's 12. Notice it says distinct, which means that we only count each of the primes once, because they all have to be different. Okay. On to problem 10. So we're given that a star b means 3a minus b, and we want the value of x if 2 star, in parentheses, 5 star x equals 1. So for this type of problem, it's probably easier to work from the outside in. So what do I mean by that? We'll start with 2 star this unknown number, but it definitely will have some value. So when we do that, we get 3 times a, which is 2, minus this unknown number, and it's equal to 1. So 6 minus something equals 1, so this something is 5. So that means that 5 star x has to be equal to 5. So if we do 5 star x, we get 3 times 5 minus b. Or sorry, not b, x. And that's equal to 5. So we have 15 minus x equals 5, so x must be 10. Alright, I'll wait a second if anyone has any questions. Okay, cool. Let's keep going. So we want to know how many 2-digit numbers satisfy the following property. When the number is added to the number obtained by reversing its digits, the sum is 132. So we can write a 2-digit number as 10 times a plus b, and this is equivalent to the 2-digit number AB because we're in base 10, so this A is multiplied by 10. So when we reverse the number, we would get 10B plus A. And when we add these up, we'll add 10A plus A as well as 10B plus B. So we get 11A plus 11B. And we're told that has to be equal to 132. So we can divide by 11 on both sides. We'll get A plus B equals 12. So we need to know the number of pairs of AB so that they add up to 12. But they also have to be single-digit numbers because they're forming a two-digit number. So each of A and B is one digit. So the number of possible pairs, we can list those out easily. 9 and 3, 8 and 4, 7 and 5, 6 and 6. And then these ones can be swapped for 39, 48, and 57. And notice you can't flip 6, 6, so there's just 7. Oh, yeah, I'll send the PDF again in the chat if people didn't get it. Oh, sorry. I meant to send that to everyone. Okay. Oh, with the work, I can, yeah, I'll see if I can save that after. I'm actually erasing as I go, but I'm recording this, so you'll be able to see this on YouTube later. It'll be on my channel. Yeah, sure. I can, yeah, that's fine. I'll send a link out. Alright, so I think this question, no one had any problems with it, right? Okay, on to question 12. We're told that Jefferson Middle School has the same number of boys and girls, and that 3/4 of the girls and 2/3 of the boys went on a field trip. We want to know what fraction of the students were girls. Okay, so we can just assume that there are 12 boys and 12 girls. And the reason I'm using 12 is because they're using fourths and thirds. So we need a number that's divisible by 4 and 3. Otherwise, we will have fractions of a student, and that would be a problem. So we can use 12 and 12, and then we can just scale this up based on however many students there are. So if 3/4 of the girls went on the trip, that would be equal to 9 girls, boys. And then 2/3 of the boys went on the trip, so 2/3 of 12 is 8. So we just want the fraction that's girls, which would be 9 divided by 9 plus 8, which is also 9 over 17. Alright, any questions about that? Alright, we have two numbers randomly selected from this set of 6 numbers, and then we multiply them together. We want the probability that the product is 0. Just from a bit of testing, it's pretty clear that for the product to be 0, one of the numbers actually has to be 0. Any other two numbers, you'll get either a positive or a negative number, but definitely not 0. So one way that we could do this is just use probabilities. So we'll start by finding the probability that the product is not 0. And the way we would do that is say, what's the probability the first number is not 0? Well, it's a 5/6 chance. Right? 1 out of 6, you'll get the 0. The other 5 times, you'll get -2, -1, 3, 4, or 5. And for the second number, well, one of the numbers has already been chosen, and we decided it wasn't 0. So the probability that the second number is also not 0, there's only 5 numbers left, and 4 of them are not 0. So remember, this is the probability that the product is not 0. And this is equal to 4/6. We can cancel the 5s, which is also the same as 2/3. And the probability that the product is 0 would just be 1 minus this probability, because 1 is the probability that the product is 0 or not 0, which, yeah, link to my YouTube channel. I'll paste it after the discussion. I don't want to interrupt right now. Okay, so this 1 represents the probability that the product is either 0 or not 0. And obviously the product has to be one of those, 0 or not 0. So that's a 100% chance, or probability 1. And then 2/3 is the chance that the product is not 0. So the probability that the product is 0 would have to be 1/3. And another way we could solve this problem, I'll present a second way, is to find the total number of different ways we could pick the two numbers. So there would be 6 choices for the first number, 5 choices for the second number, but we would have to divide by 2 because picking 3 and 4 is the same as picking 4 and 3. So I've counted this twice when I only want to count it once. To account for that, I'll divide by 2. And that's 15. And now to find the number of products that are not 0, it would be 5 times 4 divided by 2. Because 0 is not an option, so we have one less option at each step. And then I divide by 2 for the same reason. So that's 10. So that means there are 5 products that do equal 0. And that's pretty clear, it's just 0 with each of the other numbers. So we also could have done that. But in any case, there are 5 products that have 0, 15 total products, so 1/3 chance. Alright, hope that was clear. I've given 2 solutions. One is sort of a probability way, and one is actually counting the number of ways. Alright, problem 14. Carl's car uses a gallon of gas every 35 miles, and his gas tank holds 14 gallons when it's full. So we're told that he starts with a full gallon or full tank of gas, drives 350 miles, refills for 8 gallons, and then continues driving. He arrives with his tank half full. We want to know how many miles he drove. So at the start he has 14 gallons, and he drives 350 miles. Well, that's going to use 10 gallons because 350 divided by 35 is 10. So he's down to 4 gallons. And then we're told that he refills for 8 gallons, which would bump him back up to 12. And then when he arrives at his destination, his tank is half full, which would be half of 14. Obviously that's 7 gallons, which would mean that he drove for another 5 gallons worth of fuel. And 5 times 35 is 175. So that means he drove another 175 miles. And if we add this up, 525. So our answer is A. Alright, that's probably one of the easier problems so far. So problem 15, we want to know the largest power of 2, that's a divisor of 13 to the 4th minus 11 to the 4th. Well, this certainly seems like it would be pretty hard if we actually had to calculate that. So we'll use a trick that's known as the difference of squares. So if we ever have a squared minus b squared, so the difference of two squares, we can rewrite that as the product of their sum and difference. And why does this work? Well, using the distributive property, we would multiply the a by the a minus b, and then the b by the a minus b. So multiplying a by a minus b, we would get a squared minus ab. And then multiplying b by a minus b, we would get ab minus b squared. And then we have to add this up. So the positive ab here cancels with this negative ab, and we're just left with a squared minus b squared. So when we look at the original problem, we don't actually have squares, but we do have fourth powers. And fourth powers are also squares, because it's 13 squared squared minus 11 squared squared. So that's the same as 13 squared plus 11 squared multiplied by 13 squared minus 11 squared. We're basically treating 13 squared and 11 squared as the new a and b. So even though there's a square themselves, you can just think of it as one number. And now it's a bit easier because we can just solve it normally now. These numbers are not too terrible to work with. 169 and 121 adds up to 290, which is 2 times 145. So just one factor of 2 there. And for this other term, we could use subtraction. We could also apply the difference of squares again, which I will do just to show that again. So it would be 13 plus 11 times 13 minus 11. And that's 24 times 2, which is 48. And if you do subtraction with 169 and 121, you'll get the same thing. And 48 is equal to 16 times 3. So there's the biggest factor of 2 there, or power of 2, sorry. And we have this 2 from over here. So if we combine them, the largest power is 32. All right, any questions? Cool. So we have Annie and Bonnie who are running laps around a 400-meter oval track. They start together, but Annie runs 25% faster, so she's pulled ahead. And we want to know how many laps she'll have run when she first passes Bonnie. So when she does pass Bonnie, she'll have run x plus 1 laps if Bonnie has run x laps. And this ratio also has to reflect the fact that she's 25% faster. So that's, 1.25 over 1. And if we multiply both sides by x, we'll get that x plus 1 equals 1.25x. If we subtract x from both sides, we'll get 1 equals 0.25x. And that means that x equals 4. So we might be tempted to just circle 4, but we want to know how many laps Annie has run. And because Annie's the faster one, she's actually run one extra lap. So that would be 5. And just the reason I used x plus 1 here is because when you pass someone, you'd basically be running, you'd have run one more lap than them. Okay, problem 17. We have an ATM password that's composed of 4 digits, 0 through 9, and repeats are allowed. But we also have that no password can start with 911, so we want to know how many passwords are possible. So we'll start by finding the total number of passwords. Each digit has 10 possibilities, since there are no restrictions on repeats or anything. So that'll be 10,000 possibilities. But we have to take out the sequences that start with 911. Well, how many sequences start with 911? That would just leave us with the last digit, which could be anything from 0 through 9. So there's just 10 of those. So we just subtract 10. And we have 9,990. Okay. Problem 18. Oh, this is a good problem. So we have an all-area track meet with 216 sprinters in a competition. The track has 6 lanes, so 6 people compete at a time. The losers are eliminated and the winner continues. So we want to know how many races are needed to determine the champion. So first we could imagine having 36 races, and since each race would have 6 people, that would involve all 216 people. So it's 36 races, 6 people each, all people involved. 36 races can only have 36 winners, so we've just had 36 races and there are 36 people left. Now these 36 people could compete in 6 more races, each of which would have 6 people. So that would add another 6 races, and we would still have 6 winners. And then in the final race, there's 1 more race and 1 winner, as we want. So we could add 36, 6, and 1 to get 43. Another way we could do this is say that we need to eliminate 215 people, since we want to be left with 1 winner. And we also know that each race eliminates 5 people. So we could do 215 divided by 5 to get 43. So that's a faster way to get it. We don't have to imagine like having different rounds, right? Okay. Problem 19. We have the sum of 25 consecutive even integers is 10,000, and we want the largest of them. So the middle number, the 13th consecutive integer, must be the average of all the numbers because they're all going in sequence. So we can do 10,000 divided by 25 to get 400. And I'll show you what I mean. So the middle number is 400, and then there are 12 more numbers on each side, but you can pair them up. So these two would add up to 800, but their average is still 400. So you can see the average of all the numbers would be 400, and this would still work. So we want to find the last number, and that means we just have to add 2, the number of times that are in between them. And since we need to add 2 12 times, our final answer would be 424. So since there are 12 numbers, the to the right, we add 2 12 times. Okay. Problem 20. So we have that the least common multiple of A and B is 12. The least common multiple of B and C is 15. We want to know the least possible value of the least common multiple of A and C. So let's do a little chart here. And we'll add a column for the answer that we get. So one possibility is to have 12. Oh, we won't use 12. I'll use B as 1. And then, for example, A could be 12. C could be 15. But the least common multiple here would be 60. So we can probably do a little bit better. And one thing that we can notice is that this 1 does not factor into the least common multiple of A and C. And to make the least common multiple of A and C as small as possible, we want A and C themselves to be as small as possible. So the way to do that would be have B be equal to 3, since it's a common factor of 12 and 15. And then we could have A be 4 and C be 5. And that would give us a least common multiple of 4 times 5, which is 20. There isn't really like a good way to do this. You just kind of have to do some trial and error and have some instinct on what number would be best for B. Okay, on to problem 21. So we have a box with 3 red chips and 2 green chips. And we want the probability that 3 reds are drawn if we draw chips until all the reds are drawn or all the greens are drawn. So we're drawing 5 chips, but we might stop early if we get 2 greens right away, for example. But one thing we can notice is that suppose we did draw the 2 greens, which I'll use G, and we didn't actually get to draw the reds, which were coming later. Well, we can still write it all out, but we can see that the last chip would have been red. And think about it, if the last chip is red, that means that all the greens were drawn before that. And if the last chip drawn is green, then all the reds must have been drawn before that. So the last chip is the opposite of whatever was achieved. So the probability that all the reds are drawn is just the probability that the last chip is green if we do draw all 5. So the probability that 3 reds are drawn, same as the last chip being green, which is a 2/5 chance, just because there are 2 green chips and 5 total chips, right? The last chip could be any of the 5, but only 2 of them are green. All right, question 22. We have a rectangle DEFA. It's 3 by 4 with DC equals CB equals BA. We want the area of the bat wings, which is this shaded area. So we'll use DA as 3 because it's a little bit easier, and just because the diagram seems to support that. We're told that DC equals CB equals BA, so each side is 1, and the height is 4. So bat wings are not very easy to calculate, but what we can do is use the area of the rectangle, which is 12, 3 times 4, and subtract every white triangle that we see. So we can start with EDC. There's a right angle here, so we can use base times height divided by 2. 1 times 4 divided by 2. This triangle has an area of 2. Same on the other side. And then for the triangles BC, call this point X, and EFX, the base over here is 3. So the triangle EFX is basically 3 times bigger than CBX. It's sort of scaled up 3 times. That also means that the heights will be scaled by 3 times. So they're split 1 to 3, which basically means the height for the smaller triangle would be 1, and the height for the bigger triangle would be 3. And to find the area of these triangles, we'll use base times height divided by 2 again. So 1 times 1 divided by 2 is 0.5. And the bigger triangle, 3 times 3 divided by 2 is 4.5. And then I'll add in the minus 2's from before. And if we compute this, this is 12 minus total 5 from here. So 12 minus 5 is 7, minus 2 is 5, minus 2 is 3. That's problem 22. Okay, problem 23. We have 2 circles centered at A and B, and they pass through the other circle's center. Trying to draw these circles as equal as possible. And then I'll say this is the center, this is the center, A, B. I wonder if I can make this bigger. Okay, that's probably fine. And then we're told that the line containing A and B is extended to intersect the circles at C and D. C and D. And then the circles intersect at 2 points, one of which is E, so we'll just use the top one. We want the measure of CED. So connecting like so. We want this angle in between there. So the first thing to notice is that this triangle EAB is very special. Because B is the center of the circle, the distance from B to A is the same as the distance from B to E. And for the same reasons, A to B is the same distance as A to E. Remember that the centers lie on the circles. So that makes ABE an equilateral triangle. So this angle here is 60. And then the angle EBD is the other part of a straight line. So that means that this 60 angle and this unknown angle have to add up to 180. Right, so we have EBA plus EBD equals 180 degrees. So that makes this 120 degrees. And then using the same logic that we used before, the distance from B to D is the same as the distance from B to E because B is the center of the circle. So that makes BED an isosceles triangle. So these two angles here must be equal. And since the angles must add up to 180, the two base angles here have to add up to 60, since 120 plus 60 is the full 180. So that means that each of the base angles has to be 30 degrees. And 120 plus 30 plus 30, sure enough, is 180. Now, looking back at CED, we can see it's this 60-degree angle here, plus a 30-degree angle here, and we could use the same logic on the other side, so this would also be 30. So 30 plus 60 plus 30, 120. Any questions? I can go over that if I can talk through it again if necessary. All right. Problem 24. We're told that the digits 1 through 5 are each used once for a 5-digit number. And we want to know P, but we're also given a few restrictions. P is the first number. We're told that PQR is divisible by 4, QRS is divisible by 5, and RST is divisible by 3. The one that's most interesting here is QRS divisible by 5, because that immediately tells us that S has to be 5. And for RST to be divisible by 3, we know that the sum of the digits in this number has to be divisible by 3. So the sum of the digits could be 3, 6, obviously not possible here. Could be 9. We could get that using a 1 and a 3. Could also be 12. We get that by using a 3 and a 4. So it's not immediately clear which. But we also know PQR has to be divisible by 4. Let me just make this clear. This is for R and T. Okay, so PQR has to be divisible by 4. That means that R has to be an even number. And for these possibilities, 4 is the only even number, so R has to be 4. And that means T has to be 3. So now we're looking at PQR has to be divisible by 4. We have two options, either 1, 2 or 2, 1. If we use 2, 1, 4, it's not divisible by 4, but if we use 1, 2, 4, it is divisible by 4. So that means that this is the correct solution, and 1 is our answer. So the motivation for this problem is basically using this divisible by 5 first, because it's the easiest condition and it's the most restrictive, right? We immediately can find one of the numbers. And then for the other two conditions, I did it using the multiple of 3 first, but you could have done it in either order. You could first see that R has to be a multiple of 2, and then when you do the multiple of 3, you would get the same thing. Okay, I'll do the last problem now. So we're given a semicircle, which is inscribed inside an isosceles triangle with base 16 and height 15. And the diameter of the semicircle is contained in the base of the triangle. We want to know what the radius is. So I'll draw the height here, that's 15, and that's going to split the triangle in half. So each of these is 8, and this is 15. And because this is a right angle, we can use the Pythagorean theorem here. So if this is x, then 8 squared plus 15 squared equals x squared. 8 squared is 64, 15 squared is 225, that adds up to 289. And 289 is 17 squared. So this x is actually equal to 17. And to find the radius of the semicircle, we can draw a line like this. So it starts from this middle point and it touches the side here. And One very useful thing to know is that when you have a tangent, basically this circle, or the semicircle, is meeting the sides of this triangle at exactly one point. So you can imagine a line and a circle. Normally they'd intersect in 2 points. But if you slowly move the circle away, then these 2 points of intersection will get closer and closer until they can eventually become just 1 point. And when it's just 1 point, then this becomes a right angle. So now we can use areas to finish the problem. So just looking at this triangle here, I'll call it A, B, I guess this would be C, so this can be D. Just looking at triangle ABD, the area of that triangle would be 8 times 15 divided by 2, which is 60. But there's another way we could find the area. We could use AB as the base and DE, I'll say. We can use DE as the height. And AB is 17. The height we don't know yet. The height is also the radius, notice that. So that's what we want to find. If we do 17 times the height, or the radius divided by 2, we should also get 60. Right? The area of this triangle hasn't changed, so we should still get 60. And if we just rearrange a little bit, we'll get 17 times the height is 120, or the height is 120 divided by 17. So that's B. Okay, those were all the problems from the 2016 AMC 8. Hope this was helpful. If you did find this helpful, please consider donating to my GoFundMe to support local hospitals for COVID-19. Thank you.